The purpose of this video is to teach you how to use trig to find a missing angle in a right triangle. But first we need to talk about how we name the sides and the angles in a triangle. So we typically use all capital letters whenever we're talking about an angle. So I have angle A, angle B, and angle C. All of those would be capital letters. And then we use the same three letters to name the sides. So side A would be opposite of angle A. So if this is angle A, the opposite side would be this. For the sides, we use lowercase letters. So this would be side A. Angle B, opposite of that would be side B. And for angle C, opposite of that would be side C. So we've talked about the three trig functions. Those are sine, cosine, and tangent. And we use these three trig functions anytime we're trying to find a missing side. That's what we did in the lesson right before this. Today, we're going to look at the inverse sine, the inverse cosine, and the inverse tangent. And those are the buttons that we're going to use on our calculator when we're trying to find a missing angle. So you want to make sure you understand the difference. They're going to be really close to each other on the calculator. They look very similar. We only use the inverse trig functions when we're finding an angle, and we use the sine, cosine, and tangent buttons whenever we're finding a side. The way that that works is we have an equation. The sine of angle x equals 1/2. Now we already know from previous conversations that x has to be 30 degrees here. We've talked about our special right triangles. We know that the ratio for sine is opposite over hypotenuse, so in a 30-degree angle we have 1/2 or 1/2. Now we're going to talk about how we actually use the calculator since we already know what the answer should be. So if this is our equation, in order to find x, since I'm trying to find an angle, I'm going to use the inverse sign of whatever fraction or decimal that is provided. So if I type in my calculator the inverse sign of 0.5 or 1/2 or whatever they've given you, then that's going to give you whatever the angle measure is. So in this case, when you put it in your calculator, you get 30 degrees, which is good because we knew ahead of time that the answer should have been 30 degrees. So here's the type of problem that we're going to have to use this on our homework. So I've been given an angle that I'm trying to find. So this angle right here is x degrees. I was given two sides. Based on this angle, side 5 is opposite to it, and side with 8 is the hypotenuse. So the trig function that uses opposite and hypotenuse is sine. So my equation is going to be sine of the angle equals opposite over hypotenuse. Now we're in a situation, since we're trying to find an angle, we need to remember to use the inverse trig function. So x is the inverse sine of the fraction 5 divided by 8. So when you enter this in your calculator will give you 38.682187, and that just keeps going. For our angle measures, we're going to round to the nearest degree. So that's going to be this place right here. So it's either going to be 38 degrees or it will go up to 39 degrees. We're going to look just to the number to the right of that. We don't care what any of these other numbers are. So based on this 6, since 6 is greater than or equal to 5, that means that we are going to round this up. So x is going to be 39 degrees. So this problem looks very similar. Here's the angle I was given. This time I was given the adjacent side and the hypotenuse. So the trig function is going to be cosine. So the cosine of my angle equals 5/8. We're going to use the inverse trig function, and we're going to round our answer to the nearest degree. So this one would be 51 degrees. So the inverse cosine of 5 divided by 8. There's another example. This time we're using tangent because it's opposite and adjacent. So the tangent of angle x is 5 over 8. When I do the inverse trig the inverse tangent of 5 over 8, rounded to the nearest degree, I get that x is 32 degrees. For the last 3 examples, I've used 5 over 8. But I got 3 completely different answers. I got 39 degrees, 51 degrees, 32 degrees. Now that should tell you how important it is for you to use the correct trig function, because if you don't use the correct trig function, you will get the wrong answer. So the next type of problem that we're going to solve is solving triangles. All triangles come with 6 parts. They each have 3 angles and 3 sides. When I ask you to solve the triangle, I'm asking you to find all the missing angles and all the missing sides. I'm always going to give you 3 of the 6, and you have to find the other 3. Now, there's a lot of different places that you can start for this. There is no right or wrong for where you have to start. I'm just going to start by finding angle A first. So if I look at angle A, I only want to use the given information to find all of my answers. If I use an answer that I found to find the next answer, if I find this wrong and then use that wrong answer to find other answers, every answer I find after that is automatically going to be wrong. So I only want to use the information that they gave me, because I am 100% sure that these 2 answers are correct since they were given. So using these 2, this would be adjacent, this would be opposite. That means it's going to be tangent. So the tangent of your angle is A, is opposite, so the side opposite would be 7, over adjacent, which would be 3. Since I'm finding an angle, I need to make sure that I'm using the inverse tangent of 7 over 3. And when I put that in my calculator, since it's an angle, I'm going to round to the nearest degree. I get 67 degrees. So this angle, angle A, is going to be 67 degrees. Next, I'm going to find angle B. I'm still only using the 3 and the 7. So from angle B, I was given opposite and adjacent, so that's going to be tangent again. So tangent of my angle, which is angle B, is opposite over adjacent. This time it's 3 over 7 instead of 7 over 3. Again, I'm finding an angle, so I'm going to do the inverse tangent of 3 over 7. And I'm going to round my answer to the nearest degree, so that's 23 degrees. So angle B is 23 degrees. We already know that the 3 angles of a triangle have to add up to 180 degrees, so that's a good check. 90 plus 67 plus 23 is 180 degrees, or you might remember that the acute angles of a right triangle are always complementary, meaning these 2 have to add up to 90 degrees, and they do. The last thing we're trying to find is side C. Remember, I know this is side C right here because it is opposite to angle C. Since this is a right triangle and I know 2 out of the 3 sides, I'm not going to assume that it's a special right triangle because it's not a 30-60-90 and it's not a 45-45-90. That means I have to use Pythagorean theorem. So a squared plus b squared equals c squared. And really, a and b don't matter when you're doing Pythagorean theorem. If I'm following it this way and I actually do a squared and b squared, I really should be labeling it 7 squared plus 3 squared. So I have 49 plus 9 equals c squared, which means that 58 equals c squared. So I need to take the square root of both sides. When I do that, since it's a side, I'm going to round this one to the nearest tenth, and I get 7.6. It is really important to ask yourself if your answers seem reasonable. I know from my three sides the hypotenuse should be the longest side, and in this case it is, so that means it's reasonable. If I remember back to a previous chapter, I also know the smallest angle is opposite the smallest side, so my smallest angle is across from my smallest side. My largest angle, 90 degrees, is opposite my hypotenuse, and then my middle angle, 67, is opposite the middle side. So these answers would seem reasonable. Now we're going to look at what happens if I've given you an angle and a side. If they provide you one of the acute angles, the easiest piece of information to find is the third angle, because I know these two have to add up to 90, or if you insist, these three have to add up to 180. That means that angle A is going to be 63 degrees. Remember, I'm not going to use this to find side A or side C. I am only going to use the given information. So the 3 and the 27 degrees. It does not matter if you find side A first or if you find side C first. Just pick one. If you want to find side A first, using this angle, this side, this is opposite of the 27 degrees, and this side, side A, is adjacent, so that would be tangent. So tangent of my angle equals opposite over adjacent. So now, if you're struggling to solve these, we've been doing equations like this, you can set this up as a proportion. So I can make this over 1 because anything divided by 1 is itself, and we know that in our proportions we cross multiply. So this would be A times the tangent of 27 equals 1 times 3. And so now, if I wanted to solve this equation, I would divide both sides by the tangent of 27. The reason why I do that is because these two are going to cancel out. Tangent of 27 divided by tangent of 27 is 1. So A is going to be what I get when I enter 3 divided by the tangent of 27 in my calculator. So that is going to get me about 5.9 if I round to the nearest tenth. So this side right here is going to be 5.9. The next thing that I need to find is side C. Again, I'm only using angle 27 degrees and this side of 3. So if I use this angle, this is opposite. I'm trying to find hypotenuse. That would be sine. So the sine of 27 equals opposite over hypotenuse. So again, we can turn this into a proportion and cross multiply. So I have C times the sine of 27 equals 3 times 1. Then divide both sides by a sine of 27, and C is going to be 3 divided by the sine of 27. So I'm going to enter this into my calculator, and I get that C is 6.6. So my hypotenuse is going to be 6.6. Now I'm going to look at my three sides. I have 3, 5.9, 6.6. This seems reasonable since this is the largest side and it's the hypotenuse. Then I'm going to look at the relationship between the smallest angle and the smallest side. So the smallest angle is 27. The smallest side is 3. They are across from each other. The largest angle is 90, the hypotenuse is 6.6, and the middle angle is 63, the middle side is 5.9. So these answers appear to be reasonable. The last thing that I want to talk to you about is making sure that you never use your 90-degree angle. So if this is my triangle, that means that this would be side C, this would be side A, and this is side B. Some of you want to do like sine of angle C. The reason why we can't ever use our 90-degree angle is because when we do the ratio for sine, that's opposite over hypotenuse. Well, the problem with using this angle is that the opposite is the hypotenuse. So we can't ever do that. So never use your 90-degree angle. You can only use your two acute angles as the angle you use for your trig functions. So now you should be able to solve for a missing angle, and you should be able to solve a triangle.